Hello everyone, myself Gaikwad Namit Ramesh. Today I am going to explain about the lead acid and lithium acid battery. So first I will explain about the lead acid and then second I will explain about the lithium acid battery. As we go few years back, the mostly battery used in the EVs or the electronic gadgets were the lead acid battery. But today's in now the trends, the battery mostly used in electronic gadgets or in the EVs, the batteries are the lithium ion battery. So lead acid battery is the oldest types of rechargeable battery which was invented in the year 1859 by the French physicist Gaston Plante. Lead acid battery can be classified or known by the secondary battery. Now this battery is a consist about the metallic lead dioxide, lead sulfate and sulfuric acid. A negative electrode that is the anode of this battery is made of a metallic lead having some minor fractions of calcium, tin and antimony and positive electrode is cathode made of out the lead oxide in a various composition. This is the internal structure about the battery. Now in this slide I am going to explain about the working principle in the battery the discharge. Now this is the internal diagram. When the discharging process or the car is running or a car is low at negative, that is anode. The lead reacts with the hydronium ions plus water and there is gain about the lead sulfate. Along with that there is a loss of electron. Means at negative at anode process this at anode electrode there is a reduction and whatever there is a loss of electron it is gained by the positive electrode, that is a cathode. There is a gaining of electron, this is the oxidation. Means lead dioxide reacts with the hydronium ions plus sulfate ions plus gaining of electron, formation about the lead sulfate. This is a process occurring while discharging when a car is running or load. Now we'll talk about the charging. In the battery, the charging, the lead sulfate reacts with the hydronium ions and there is a gain of electron and formation about the lead. This is a process formation at the negative, that is the cathode. And at positive, lead sulfate reacts with the water and formation about the lead dioxide hydronium ions plus sulfuric ions and electron. This is a process formation at the positive. This is a process formation at the charging. Now, next we talk about the lithium-ion battery. Lithium-ion battery is a rechargeable battery commonly used in a portable electronics like the smartphones, laptops, electric vehicles, even a large storage system like a solar storage. Now, lithium-ion battery, the cathode, positive electrode made of a lithium metal oxide, anode usually made of a graphite carbon, it stores lithium ions during the process. It consists of electrode, liquid or gel that allows the movement of lithium ions. Also, it has a separator, a thin polymer membrane which avoids from a short circuiting, that is a cathode and anode from a touching. A working principle, this is the internal diagram about the lithium ion batteries. At anode, whatever the ions are there, there is a movement of lithium ions from anode to cathode. So this process is forming during a discharging. The lithium ions moves from anode and passes through the electrode until they reach the cathode and electrically neutralize. The lithium ions are small enough to able to move through a micromembrane separator. This is a micromembrane separator by which they are moving from. They are so small or tiny they can move from anode to cathode. Lithium-ion batteries are capable of having a very high voltage and charge storage per unit mass unit volume. This is the property of lithium-ion battery that they are the small in size. Lithium-ion batteries are small in a size, but they have a capable of having a very high voltage and charge storage comparison to lead acid battery. This is a process working principle at the discharging. Now charging. At cathode, whatever the ions was there During the charging cycle, the process is exactly opposite the recharging cycle. The cobalt dioxide reacts with the lithium ions and gaining of electron by formation of the lithium cobalt dioxide. A lithium ions flows from cathode to anode and electron flows from anode to cathode. Means lithiums are flowing from cathode to anode and reverse of that electrons are flowing from anode to cathode as the battery is charging. When discharging, the lithium ions are moving from cathode to anode and electrons are flowing from anode to cathode when there is a charging process, and this process is steady flow of electron as long as lithium ions are making their way from one electrode to next, and this process continues. So this was the process that is charging. Now we'll talk about the density. So typically there are two types of density: gravimetric energy density, volumetric energy density. Gravimetric energy density means amount of energy stored per unit mass. This is energy which is stored per unit mass. Energy is stored per unit mass. And volumetric energy density, the amount of energy stored per unit liter. So about we talk about a lithium ion batteries. Gravimetric energy density is about 150 to 250 watt hour per kg, and volumetric energy density about 300 to 700 watt hour per liter. So these are the densities about the lithium ion battery. And we talk about the range. The range in electric car means in a single charge how long the car can be run. Typically, EVs, electric vehicle using a lithium-ion batteries having a driving range of 200 km to 600 km on a full charge. In a single charge, it can run about 200 to 600 km. But some high models like Tesla model, yes, long range can go over 600 km. So this is the capacity about the high models Tesla model. We talk about the Indian car EV, that is Tata Nexon EV Prime. So its battery size is about 30.2 kilowatt hour, and in a single charge it can run about 312 kilometer. Whatever this range are there, this range is not constant over the year. There is a decreasing of range as uses of battery depending upon uses of the battery. So at starting the range about 312 kilometers. Now next about the life cycle. We'll talk about the life cycle. This battery manufacturing, as we know, this battery, lithium-ion battery, are made about lithium, cobalt, nickel, graphite, which are processed and finally they are assembled into cell. The cells are combined into models and then battery pack. Now, active use stage. As we know, in a full cycle, it consists about the or the addition of one complete charge plus one complete discharge. It consists about a one full cycle. So now one lithium ion battery consists about a 500 to 3000 cycles depending upon the quality and the uses, depending upon which around 8 to 15 years are the battery lives of the EV. As we know, lithium-ion batteries are new in the market, so nobody has used a battery more than 12, 13, 14 years. Nobody has used. So it is new in the market. So research are saying it can about a life about it can be about 8 to 15 years of battery depending upon the uses. So this was about the lithium-ion batteries. Thank you.